Welcome to EDU World Space.
Okay, so this is the free body diagram for the car. Since the front wheels are free to roll, therefore there's no static friction at point A. So let's apply the force equilibrium for this question. So we have the net force along the horizontal direction is equal to 0, which is equal to Fb minus F cosine 30 degree. Fb is the friction at point B, and F here is the towing force we are looking for to
Here's
determine.
a clean and professionally formatted
If
presentation.
we do some arrangement
of the
here, we have
calculations
F
shown in the
is
image.
equal to Fb over cosine 30 degree. And we know Fb can be equal to mu s
Application
mv.
of the work
Mu s
energy
is the
theorem, wet.
coefficient
From the
of the
work
static
energy
friction.
theorem,
mv
the
is the normal
force
force at
F
point
is
B.
given by
So if we
F
do some
equals
arrangement
frac
here, we have
text
mv
KE,
is equal to
where
F cosine 30 degree
KE
over mu
equals
s.
kinetic energy.
So now let's take a look at the
S
moments
stopping
above point
distance.
A.
Then
And this
given
equation
for
here
object A, FA equals frac
describe the
100,000 0.10.
total moments above
For
point
object
A.
B, FB equals frac
And
225,
the value with the meter
1500
here
equals
are the lever
0.15
arm for
text
each
text
force.
n.
So
Then
we
force
consider
ratio
the
frac FA,
counterclockwise moment is
FB
positive and the
equal frac
clockwise
0.10,
moment is
0.15
negative.
equal frac
So if
2
we do some
nulls.
arrangement here,
On the
eventually we'll
box
have
frac
the
FA,
towing force
FB.
is equal to
Would you like a
W times
PDF
1
version
meter
of
minus
this
MB times
explanation?
2.5 meter over negative sine 30 degree times 0.75 meter plus cosine 30 degree times 0.3 meter. W here is the weight of the car, which is the gravity of the car. And we also know that MB is equal to F cosine 30 degree over mu s. So now we can use F cosine 30 degree over mu s, substitute for MB. So we have force F is equal to W times 1 meter minus F cosine 30 degree over mu s times 2.5 meter over negative sine 30 degree times 0.75 meter plus cosine 30 degree times 0.3 meter. So if we do some arrangement here, eventually we'll have the towing force is equal to such equation here. So now let's determine the value for the towing force. So we know the gravity, which is the weight of the car, is equal to mg. So the mass of the car is given as 2 megagrams, which is 2,000 kilograms. So if we do some calculation here, we'll have the weight of the car is 19,600 Newton. And we know the coefficient of the static friction is equal to 0.3. So now we can plug in the values back into the equation to determine the towing force. So we have towing force is equal to 2,760 Newton. And this is the answer for this question.